So this question is going to be a little bit more challenging, but yet we use the same steps as before. So yeah. So so the question is, find the dimensions of a rectangle of the largest area that has the base on the x-axis and the other two and the other two vertices above the x-axis and lying on the parabola y equals 8 minus x squared. So what the heck are they saying is pretty much I drew my parabola, which equals y equals 8 minus x squared, so it's going to be upside down and shifted up 8 units. So I'm going to put, or you're supposed to put a rectangle inside, and we want our rectangle to have the max area, the most area we could get. And so the way I'm going to start is, so a generic dimension would be x minus y, but it just shows us this distance will be x and this distance will be y units. So the area should be double, so 2xy, which will be your maximize. And this is what you have to take the derivative of. So you're trying to find the constraint, but the constraint's already kind of given to us, which is y equals 8 minus x squared, which kind of lies, which it has a relationship. So the area is equals 2x times 8 minus x squared. You could use the powder rule, but it'll be easier if you just clean it up, and it'll be finding the derivative much easier. So it'll be 16x minus 2x 2x to the third so just like before, we just find the derivative, 16 minus 6x squared, and then find the critical numbers. So you set it to 0, so 16 minus 6x squared equals 0. And so it looks like we could add 6x squared to the other side and leave 16 on the left. So if you divide 16, you get 16 over 6 equals x squared. And you simplify, it'll be 8 over 3 equals x squared. And when you get rid of that power, it'll be square root of 8 over 3. So it kind of makes sense that we're going to get a positive number. So in a sense, this is the only critical number. So square root of 8 over 3, and it would be close to 0 because if you made it, oh, screw it. So this kind of has to be the maximum. No, this will be your maximum. So you would check with your sign diagram. So you plug it into the other equation. It'll give you a positive number and a negative number. Which would you know? It's the maximum number. So we know the relationship y equals 8 minus x, which is square root of 8 over 3 squared. And so 8 minus 8 over 3 and then 16 over 3. So the dimensions would be 2 square root of 8 over 3 times 16 over 3, and those are your dimensions. So yeah.